Okay, so today I thought that we probably would skip your practical question practice number 4 because that's not gonna help you that much when it comes to your practical. But instead, what I will do is to show you how to do um, the ANOVA using all these different kind of statistics, and then how do you follow up with a post hoc test. Okay, so I'm going to show you a total of 6 different scenarios that you can do. So I'm going to show you one scenario when the data are between groups and another data are within groups. So this Excel spreadsheet, you'll be able to find it online. And then so there is going to be one that is on the between groups, another one that is on the within groups kind of design. Okay, so let's take a look at this uh, between groups design first. So we got groups A, B, C, and D. Okay, so A received no coffee, and then B drank 1 cup of coffee, and group C drank 2 cups of coffee, and then group D drank 3 cups of coffee, and then we're measuring their attention score. So all these numbers that you're seeing there are in the attention score. So now remember, this is between groups, which means that the person in here and the person in here, these are not exactly the same person. Okay, so this is one person, this is another person, this is another person, then this is another person. Okay, so the first way I'll show you how to do it is probably the easiest way, and that is for you to go to AStats A. Okay, now if you go to the AStats A website immediately, you'll go to their online web statistical calculator. So this is the one you want, the one-way ANOVA with posthoc 2-key test. Okay, and then you're gonna say, well, how many of the independent treatments do you have? Well, the number of the independent treatments that we have is this number. Okay, number of K equals 1, right? So proceed to enter your treatment data. And then what you need to do is to just basically copy and paste this. Copy and paste this onto that. Okay, and then do this a couple times. Okay, then D. Okay, and then you can just go do this. Okay, so these are all the data that you inputted in there. Okay, so it's going to tell you that there are 12 people in A, 13 people in B, 11 people in C, and 12 people in D. Okay, and then it'll give you the sum of the square, the mean square, the sum of square, the what else? They're going to give you the variance, the standard deviation, and also standard error of the mean. Okay. All right, and then so now it'll also give you the one-way ANOVA results. Okay, so the one-way ANOVA results, what it's going to give you is the number of the treatments, in terms of like the degree of freedom. So the degree freedom here is 3 for the treatment, and the degree freedom for the error is 44. So these are the number that you need, and this is the F statistics that you need to report, and that's the p-value. Okay, and so down here, so what I really like about this website is that it shows you the conclusion from ANOVA. It shows you that the p-value corresponding to the F statistic of the one-way ANOVA is lower than blah blah blah. So this really tells you that this is a significant difference. Okay, and then therefore there is a follow-up 2-key HSD test. Okay, and then now what the HSD test, so it basically tell you exactly what what the Tukey-Kramer does. Okay, and then it even gives you the actual Q table here at Duke University. So if you go there, it'll tell you what the Q statistic is based on. Okay, and then so basically, so the one that I mean, you can read this for your better understanding of it. You know, I'm not gonna go over that. But over here, what it's gonna tell you is these are all the pairwise comparisons. Okay, so it's gonna tell you group A versus group B, A versus C, A versus D, B versus C, B versus D, and C versus D. Okay, and then so here, what it's just showing you is that A versus B, there is a significant difference, you know, so all the pairs are significantly different except C versus D. Okay, now when you look at these data, what that means is that group C and group D is the only two groups that are not significantly different from one another. Okay, so this is what you need to report when you are writing your post hoc results in your results section. Okay, so that's the first way how to do it. So this is relatively easy. So that's the first way to do it. The second way to do it is to use the SPSS. Okay, so let's go to our CUNY virtual desktop and then open up the SPSS. Okay, and so in the variable view, you want to enter it as group. Okay, so then later you're gonna give it, and then in values, what you need to enter is value of 1 and when the label is. So this is group A, and then okay, and then value 2 is group B, right? And value 3 is group C, add, and then value of 4 is group D. Okay, so add and then click OK. And then this one, what you need to put in here is the attention score. Attention score. Okay, and then this one, just leave it alone. You don't need to do anything to it. And then now let's go to our data view. Okay, and then what you need to do in the data view, oh sorry, there's something I forgot to do. So go back to the group data, and then over here, I think you want to give it that this needs to be nominal. Where is nominal? Where is type? Well, I don't think it matters if you say it's nominal or not. Okay, but anyway, so you can go back to this, and then what you need to do is just to copy and paste these data. So that's group A. So we're copying group A right now. So here you just need to say that this is group A. So copy this down. Okay, and then go back to our Excel. So that is group B, right? So that's group B. And then let's go back to our Excel as group C. Okay, and then that's 3, group C, and then let's go back to our Excel, and this is group D. Wait, I don't think I copied it. I don't think copy, paste. Okay, so group D. Okay, Okay, now let's go to analyze and then go to compare means and then go to one-way ANOVA. Okay, so the dependent list in this case is that's the dependent variable, right? So that's the attention score, and then the factor is the group. Okay, and then what you need to go to is go to options, go to descriptive, go to homogeneity of variance test, continue, and then go to posthoc and say I want to use the 2 key. Okay, where's the 2 key? Up here. Here it is. All right, and then click continue, and then click OK. Okay, so now you'll see that the data here should match up exactly what the data in AStats-A, the website just gave you. Okay, so it gives you all the data here. That's the number. It gives you the mean, standard deviation, standard error, right? And then it also gives you the result of the homogeneity variance test, which we don't really need to look at. And then that's the important part. So that's the ANOVA. Okay, so you see that the between groups degree of freedom, within groups degree of freedom. So this is all exactly the same thing as what you saw here. Okay, so here they call it error, and then in the SPSS they just call it within. So it's the same thing. Okay. Right, now let's go back to our statistics. Okay, and all right, so we're good. So significance. So you see that the results are exactly the same. Okay. Now over here, what you're seeing is the multiple comparisons with the data. So this is looking at group A versus group B, group A versus group C, group A versus group D, right? And you can see that each one gives you the significance, right? And now let's see if our significance is exactly the same. We saw that the only thing that was significantly different is between group C and group D, right? So let's see. So everything that I'm seeing here is less than 0.05, and this one should be C versus D, right? Is it C versus D? That is correct. And this one that you see, this is all should be also C versus D, right? So this, yeah, see, this is group D comparing to group C. So it should give you exactly the same number. Okay, the same results. Okay, so that's the second way to do it. Now, the third way that you can do this is to do it on Excel. Believe it or not, you can do ANOVA on Excel, and you just need to input the data analysis pack. Okay, now I show you how to do it in the previous video, so you guys can refer back to that. Okay, so essentially after you install it, you will see the data analysis here. So let's click on this data analysis, and then let's pick the one with the ANOVA single factor and click OK. And let's input the range. So you just need to highlight this range and then group by columns. Yes, we have it right. And then the output range, let's put the output here, okay, in F1. And then just click OK. Now, this would give you exactly like all the data that you're looking for, okay? So it'll tell you that your column 1, so that it would be your group A, okay? And this would be your group B, column 2, and this would be your group C, and this would be your group D. So that's, so what you can do is you can change this right now. Okay, so group A, group B, group C, and group D. So this is for us to have a better idea what they would be. Okay, so this is going to tell you the average and the variance and all that. And now SEM you're going to have to calculate on by yourself. Okay. Okay, now this is going to tell us the ANOVA value. Okay, so the ANOVA value, so you see that this is the between groups, the degree of freedom, and the within groups, the degree of freedom, and it tells you the mean square and also the F statistics, and it also tells us the p-values. Okay, and you can see that this and the SPSS and the A website all give you exactly the same F value and the P value. Okay, now you're probably thinking that, well, okay, so I have a significant P value here. Well, I mean, where's the post hoc result? Well, unfortunately, Excel does not do the Tukey-Kramer for you, so you're gonna have to do it the long way. So to do the Tukey-Kramer, what you need to do is to look at this. Okay, so I'm going to actually delete these two. So you need to create a table like this down here. So that would be your Tukey-Kramer results. Okay, and so what you'll need to do, so essentially what you have here is all the possible comparison. You've got group A versus group B, group A versus C, and so forth. Okay, so you need to calculate out the differences here. So let's do that. Okay, so the difference of that means group A. So let's take the absolute value of that, and group A minus group B. Okay, and then we'll just do the same thing for group A versus group C, which is in this case, right? And then now let's do group A and D equals absolute of A minus B. Okay. Okay, now let's do B versus C, absolute value of B minus C. Okay, and then the absolute value of B minus D. Okay, and then C versus B, so this is going to be absolute value of C minus D. Okay, so now you create this table, and then you just need to copy down how many groups are in the first group. So in this case, A. Okay, so there are 12, just 12, 12, 12. Okay. Okay, and how many people are in group B? 13. Okay, so 13, 13. Okay, here's another group B here, 13. And in group C, how many? There are 11. 11 here, 11 here, 11 here. And the rest are the group D, and that's 12 people. Okay. And the next thing you need to calculate out is this is the SE. Okay, so the standard error. And then, so now I give you the formula here. So that is, it equals the square root of 0.5, the mean square within, which is going to be this number. Okay, so 0.05 times this number. Okay, and then parentheses 1 divided by the end of group in this number. Okay, and then the end of group, plus 1 divided by this number here. Okay, and press this. Yes. Okay, now one thing, if you want, you can change this not to, like, because if you want just kind of copy down, and that's easier. So what you can do is you can go to here, and you can like literally copy down the number 243.11. I think if you round it to the hundredths place, you should be okay. Okay, and then you just copy this down. All right. Okay, so that would be the SE. Okay, now, and the last thing we need to calculate out is the Q. Okay, and that is exactly what you're seeing here in the in the Q statistics, the studentized range for statistics in the Q. Okay, so these are the critical value for the Q corresponding to an alpha of 0.05 on top and then the alpha of 0.1 on the bottom. Okay, so this is exactly what we need to calculate out for each comparison. So how do they calculate out the Q? Well, the Q is really easy. It's really just the difference divided by this SE that you calculated out. Okay, so when you're done, just drag this down, copy and paste, and then there you go, you got it. Okay, now, so the next thing, what you need to do then is to determine what is the p-value here. Is it bigger than or less than 0.05? Okay, so let's take a look at our first group. First group comparison, A versus B. So this is the Q. So I'm gonna put these down. Okay, all of these. Sorry, not. I'll put them in bold, not in color. Okay. Okay, so this is the number that we're looking for. So 5.08. All right, so 5.08, and we'll compare. And how many people do we have? We have and well, okay, so we got 40. The degree of freedom was 44 here. Okay, degree of freedom is 44. So let's go to here. So this is the degree freedom for the error term. So that's exactly what you're looking for, the degree freedom in the within here, also known as error, you can see here. So you need to look for this table, this number. Okay, so 44, 44. Okay, so it's somewhere between 60 and 40. Okay, so let's be a little bit more conservative and let's pick, let's say 40. Okay, so because we want to be a little bit more conservative. And how many treatments do we have? We have 4 treatments, okay? Because remember our K is treatment, we got 4 different groups, right? So this go all the way down. So this is the number you're looking for, okay? Now, the number in this comparison is greater than 3.79? Yes, right? So that would mean that the p-value is less than 0.05 here. Okay, and now if you go back to the Q statistics, is it greater than 4.70? It is, right? So you can determine that this is actually less than 0.01. Okay, now let's go back and say, so everything that is greater than it's 5.08, anything that's greater than 5.08, you can basically copy this over and say that this is going to be less than 0.01. Okay, now let's look at the case of 4.73. 4.73 is it greater than 4.7? Yes, it is. So in this case, it's less than 0.01. All right. Now this is smaller than both of the numbers that you see on the Q statistics over here, right? So this means this is not significantly this is not a significant result. Okay, so that means it's less than 4.05. Okay, and then I am going to highlight all of the comparisons that are statistically significant to be in red. Okay, so you can see that the results here that you did in the Tukey-Kramer in the long way is exactly the same that you got from A-Stats-A as well as as well as the same as the SPSS. Okay, so you can basically see that these are the 3 ways to do it, and there's really just nothing to it. Okay, that's it.
show LSD.
Dialog. Just go to add-ins, and then at the bottom, so it is below 0.05, so it's statistically significant. So now we have to find where the difference or degrees of freedom within points. The absolute net state under equal variance is assumed. Click continue, and click OK, and
Hello. So now
use ordinary pair t-test with an error term. Is the correction is the Okay, now let's take a look at the within groups design and how you would do the ANOVA on those. Okay, so here we have a person, well, 10 participants that are, let's say, clinically depressed. Okay, and the dependent variable they're looking at here is the motivation score. And there are 4 conditions that each of the participants went through. So they measure their baseline of the motivation score before CBT, cognitive behavior therapy. Okay, and then they measure it again after 7 days, and then measure it again after 14 days, and then measure it again after 21 days. So this is the same person that went through 4 different stages of the treatment. Okay, so this makes it a within groups where repeated measure subjects design. Okay, so now let's take a look at how you would do this in SPSS. Now, unfortunately, I don't think you can do this in ASTATS A because when you look at this, let me see. I don't think there's a way to do it. Let me see. Okay, let's see. If you do it like this, if I want a demo, I don't want a demo. Okay, so we got N of 4, N of 4, and then we enter this. So this is the number of treatment of samples. Yeah, so this only gives you of the independent treatments with the samples. So there is no way that you can use this website if you are running a within subjects design, unfortunately. Okay, so what you want to do then is to go to SPSS, our good old friend SPSS, and let's open this. And the way that you want to organize this is quite different in the variable view. So in the variable view, you want to give it something like before. So what do we name this as? Okay, so say before CBT. Okay, and then we got 7 days after CBT, and then we got, okay, I guess it doesn't like numbers, so 7 days after CBT. Okay, I'm gonna call that CBT 7 days. Okay, CBT 14 days, and then there's one more CBT 21 days. Okay, well, in this case, I'm gonna rename this. I'm gonna rename this at 0 day. Okay, 0 days. Okay, Okay, now let's take a look at this in SPSS. Okay, so now the way that it's organized, you can see that one subject goes through 4 conditions and so forth. Okay, so now this makes the copy and the paste process very easy because you can just literally copy and then go here and copy and paste. Okay, now let's go to the analyze. Okay, now you are not going to the compare means. No. You would go to this, the general linear model, under the repeated measure. Okay, so now the within subjects factor name is called the condition. Okay, and then we got 4 levels. Okay, and add and define. Let's define these 4 levels. And that's exactly these 4 levels that you want. So, and then just go to this. And now the next thing you want to know is what you want to do is go to, now you won't have any posthoc. This is why it's all grayed out, because it's the effect of the within subjects is really kind of like the subjects and plus some sort of interaction in the intercept. But that's a lot of statistics you don't have to know. But just know that these are not going to these are going to be graded out. Okay. So what you need to do is to go to the EM means. Okay. So you want to display the means for all of the conditions. Okay. Um, and then compare the main effect. And the one that you want to pick is, let's pick the Bonferroni, okay? Because we have 4 groups. Now, if you have 3 groups, then the Fisher LSD is appropriate, but since we have so many comparisons, Bonferroni is the better choice of statistics. Okay, let's click this, okay? And let's see if there's options. Okay, it's this descriptive statistics we want. And I think that's it. That's all we want. Okay, click OK. Okay, so now it tells you that the conditions are here. 1 is CBT at 0 days. 2 is CBT at 7 days. 3 is CBT at 14 days. And 4 is CBT at 21 days. And then it gives you this descriptive statistics. Okay, that's the homogeneity or variance test. We don't really care about that. I mean, sorry, that's the multivariate test. Okay, so let's go on and let's take a look. This is the one that you want, the test of within subjects effects. Okay, and over here it gives you the degree freedom for the condition. So this is the degree freedom for your numerator, and then the error for the condition, this is the degree freedom for your denominator. Okay, and then you can see that it gives you the F statistics and it gives you the significance. Okay, so you can see that this is a very small number. Okay, the p-value, so this is a highly significant result. Okay, now down here, what you need to look for in terms of the posthoc, okay, which in this case is the Bonferroni, then you're essentially looking at the comparison between 1 versus 2, 1 versus 3. So this is exactly the same thing what you saw in the previous ones. It's just that this is going to be a different test, okay? And the one that you really only need to look for is this number, the significance. Okay, so 1 versus 2 is, well, 1, so that means this is not a significant result. And 1 versus 3, this is a highly significant result. 1 versus 4, a highly significant result. Okay, so it seems like everything is significant except between the first condition and the second condition. So in other words, it seems like the baseline and also at 7 days after the CBT has started, you don't see any immediate effect. But starting at 14 days, you start to see some improvement, and at 21 days, you see a lot of improvement. Okay, so that's basically how you will want to work the problem. Okay, so that's how you would do this in SPSS. Okay, and now how do we do this in? Okay, to do this in Excel, it's actually pretty easy, but it's actually a different method you need to do on here. So let's go to the data analysis again. So the one you want to pick in this case is the ANOVA two-factor without replication. Okay, and then click OK. And then put in your data range, and then put in like the range of output. Let's say here, and then click OK. Now, so this is the thing that's on top here is essentially not that important. The what is important down here is you want to look at these numbers here. So this is the number you need to look for the degree of freedom for the column. Okay, that's the first thing you want to look for. I'm gonna highlight this. The second thing you want to look for is the error of the degree of freedom. The degree freedom of the error. And then you want to look at the F value here for the column, and you want to look at the P value here for the column. Okay, so these are the numbers that you need to know. Now, if you see that these numbers go back to the Excel corresponds exactly to these numbers. So 3, 27, 37, okay, and very highly significant, right? And then let's go back to see if that's also the case. 3, 27, 37, highly significant. Okay, so these are the results that you need to look for. Now, the next thing you want to do is you want to then create a t-test box, a multiple t-test box, because that's essentially what the Bonferroni is, right? So you want to create. Okay, so let's make a t-test comparison for all your posthocs. So the type of posthoc you want to do in the within groups is essentially a multiple t-test using the paired t-test followed by a Bonferroni correction. Okay, so that's one of the best way to do it. So here you want to generate a table with all the pairwise comparisons here. Okay. Alright, so this is going to be the t-test. So I'm going to merge and center here. And so here, that is the p-value here. Okay, so we got CBT day 0 versus day 7, day 0 versus day 14, day 0 versus day 21. Okay, and now here you got day 7 versus CBT, day 14, and now here you got CBT day 7 versus CBT day 21, and down here you got CBT, CBT, T, like test, okay. Versus CBT day 21. All right, sorry, I mean 14. So we should get 6 comparisons. So this is all possible pairwise tests. Okay, so we got 0 versus 7, 0 versus 14, 0 versus 21. Okay, and then we got 7 versus 14, 7 versus 21, and then we got 14 versus 21. Okay, so this one we don't care. So now let's calculate out the p-values. Okay, so this one you want to enter t-test parentheses. Okay, the first array followed by a comma, and then highlight the second array. So make sure that this is day 0 versus day 7, day 0 versus day 7, yes. And then tails, and type is 1. So that is a paired t-test. Okay, and the second one is day 0 versus day 14, two tails, type is 1. Okay. Now you cannot just drag this down by like a copy and paste. You can't do that. So this one, because all the arguments that you're giving it is different, so you should really do this one by one if you decide to do this on Excel. Okay, so now we're looking at 7 versus 14, right? And then this is two-tailed 1. Okay, now this one we're looking for is this versus this 2, 1. Okay, and then this is 14, right? Comma 21 days, comma 2, 1. Okay, so what are we looking for? Okay, so essentially what we're looking for is whether we're not now there's one more thing I want to add. So this is going, so you're looking for, now normally when you're looking for these t-tests, you're looking for the p-value. So all of these ones that you see are the p-values. Okay, so you're looking for p-value of less than 0.05 generally that you will look for. Okay, but not in this case. In this case, we're doing a Bonferroni correction. Now, a Bonferroni correction, what you need to look for is the corrected Bonferroni, which is, now we got 6 tests here, right? We got 6 pairwise t-tests. So what you need to do is the critical value of P following a Bonferroni. And that is 0.05, divided by 6. Okay, so essentially this is the number that you need to look for when you are looking to see whether this is significant or not. Okay, so then you just look for this. So this is P is 1, so this is a lot bigger than this, right? So that is not a significant value, so that stays. Okay, and now let's take a look at this one. So we're looking at 0.008, so this has 3 O, so this is a smaller value. Okay, so it means that this is significant, so we're going to highlight this in red. Now this, which means that this, you will move the decimal 5 places to the left, means that there's going to be 0.00007. So this is also a smaller number. So that is also a significant value. And what about this? Is this smaller than this? It's also. Okay, so that's also significant. What about this? Okay, so it seems that all of these are significant. All right, so when you are looking at this, basically what you're seeing is that the data of the motivation score between day 0 and day 7 are not significantly different from one another. Okay, and from there, what you're seeing is a significant improvement from day 14 compared to both day 7 and day 0, and then there's a further improvement at day 21 after CBT, and then this is greater than this is greater than 14 days of treatment. This is greater than 7 days of treatment, and this is greater than 0 days of treatment. Okay, so that's how you would do a Bonferroni. So this is actually an easier process compared to the between groups, the Tukey-Kramer Q statistics. Okay, so I think we're going to conclude today's lesson. Basically, that's how you would do the posthocs in SPSS, and also this is how you would do it in Excel. Okay. Any questions, please email me. And don't email me on the day of your computer practicals because you will not get an answer. Okay, I'm just going to refer you to watch the videos. All right, so if you have any questions about the videos, ask me beforehand. Please don't ask me on the day of your computer practical because that's just I'm just going to refer you back to the video. I'm going to tell you that I explain it on the videos. All right. So ask me if you have any questions. Ask me before.